This is a travel graph. It's a graph that shows a journey, and it's headed up. The graph shows how the distance travelled by a bus increased. Along the bottom of our graph we've got time, and S there is going to stand for seconds. And up the side of our graph we've got distance, and the M is going to stand for metres. And we've got different points on the graph labelled with letters just to help us work out what's going on. If a bus is travelling, then the distance it is going is changing. It started out here, 0 distance. That's distance from the start. When it's got to here, labelled B, it's now 1,000 metres from the start, and it's been travelling all that time. But here, the distance is staying flat, it's staying level at 1,000. That is when the bus is stopped. Any one of these graphs where you have distance up the side and time along the bottom, any flat bit means it is stopped. So this bus has stopped here, that's once it stopped, then it travelled, then here it stopped, so now that's 2 stops, then it travelled, here it stopped, that's our 3rd stop, and then it travelled, and we don't know what happened after that. So how many times did the bus stop? 3 times. That's because there are 3 flat bits on the graph. I'm going to jump to part C next. On which part of the journey did the bus travel fastest? On these graphs, how steep or shallow these lines are when it's travelling means something. The steeper the line, the faster the speed. So here, that's going quite fast. Here, that's not so steep, it's shallower. It's going quite slowly. So where did it travel the fastest? It's on the steepest bit of line. So if you compare that line, that line, that line and that line, which line is the steepest? You can use a ruler if you want to. This line up here, that is that steep. I've just lined the ruler up. This line here, that's the same steepness. This line here, that's shallower. This line over here is steeper still. So the steepest bit of that journey is between A and B. So which part did it travel the fastest? It is between A and B. And we know that was the fastest because it was the steepest bit. Now for part C, the speed, you need to learn that speed is equal to distance divided by time. That's a key formula you need to learn. And on this graph, distance is in metres, time is in seconds, so we will have metres, a metres number divided by a seconds number, and that means our units will be metres per second, which we write like that m/s. That slash is like the dividing symbol you use on a computer or a spreadsheet. So any answers we have for speed here will be in metres per second. Well, the first part of the journey is between A and B. So I'm just going to write down here A to B. And from A to B, what distance did it do? Well, it went from 0 up to 1,000. So the distance is equal to 1,000. And I got to divide that by the time. And the time from A to B is from 0 to 50. So that's 50. And if I do 1,000 divided by 50, now if that's a divide, they both end in noughts, you can knock a nought off both of them. So that's going to be the same as 100 divided by 5, and that is 20. So the speed that that bus is going between A and B is going to be 20 metres per second. Now the next part of the journey when the bus is travelling is between C and D. We've already said it stopped there. So if we look now at C to D, to get the speed I need to do the distance divided by the time. Now from C to D, the distance, well, the distance of C was at this point and D is up here, so I've gone up that much. I've gone up from 1,000 to 1,500. So the distance I've gone up is 500. So that'll be my distance number. And time-wise, I've gone from C along to D, because time's along the bottom, and I've gone from 100 there to 200 here. So I've gone along 100. From 100 to 200 is 100. If I do 500 divided by 100, I get 5. And I said earlier it was in meters per second, which I can write down like that, meters per second. D to E, it was stationary, it was not going anywhere, it stopped because that was flat. So the next part of the journey is from E to F, and I need to work out the speed between E and F. E is here, F is here. The distance is this distance here. That's from 1,500 up to 2,000. So from 1,500 up to 2,000, that is 500. So that's my distance number. And I have to divide that by my time number. Time goes along here. So I'm looking to see what that amount of time is there. Well, that's from 300 to 350. 300 to 350, that is 50. So my speed here will be the answer to this sum. That is 10, and that again will be in meters per second. The last bit of speed I've got to work out is what's happening between H and F. Now, there's a quick way of doing this without doing the sum. If you spot that that line there and that line there are exactly the same steepness, they both go 2 squares along and 2 squares up, 2 squares along and 2 squares up, they're the same steepness, or they've got the same gradient, that's another word we use. If they've got the same steepness, then they have exactly the same speed. So between G and H, the speed is also 10 meters per second.